They can watch it live. Oh, good. Someone else is watching live. Hello. Or it'll be recorded. So either way. All right. And so the thing in front of you, you have the answer sheet to the rationals, and then you have a note sheet. Okay. You want to have note sheets all the time, but if it helps with writing things down, the quicker we can get through it, the better. All right. So what's a function? A function is for all x values in the domain, it produces an x goes in, what comes out? So you put an x into an equation, any equation. You put an x into an equation, you want to make sure that only one y value is coming out, which happens most of the time. We use functions, we use that word all the time, and it's almost always correct. You know, we see a ton of functions. We put a number in for x, one number comes out. But we want to make sure it's exactly one number. So for all x values in the domain, it produces exactly one y value. We only want one thing coming out. If nothing comes out, then that x value isn't in the domain. So we don't even care if nothing comes out, that's okay too. And then, but if something does come out, we only want one value. Okay, and the vertical line test, that's a great way to test it if you have a picture, if you have a graph. Okay. So for every vertical line, drawn over the graph, it should only touch the graph, each line should only touch the graph one time. Because every time you touch the graph, that's a y value. So you're checking for y values. So for every vertical line drawn over the graph, each line touches the graph one time. That one time is the one y value up there. So for every vertical line that you draw over the graph, it can only touch the graph, each line can only touch the graph one time. If there is no graph there, then we don't even care about it, we don't even draw the line. Okay, so we got some pictures. We're going to determine if it's a function, but if it's a function, oh, this should say if it is a function. Cross that S out. If it is a function, we got to state the domain and range. What's the domain? All the x values. Domain is all x values, so maybe we can sneak that here. Domain is all x values. And guess what the range is? All y values. All y values. And we're going to state that in interval notation. Okay, so we'll just kind of go through it. So that'll be another practice. So domain is x, range is y. All right, we don't have the equation. We do not have the equation, but we have the picture. Is this graph a function? Every vertical line, I touch the graph one time. It only takes one vertical line. Is there ever a time where I touch the graph more than once? So this is a function. I'm going to sneak it on here because we're going to have to do function. And then we're going to have to state domain and range. So we'll do domain equals. Oh, can we see that? Okay, so domain is x values. You go left to right. So domain go left to right. Domain is x values, so it's left to right. So what's my first left? -6. And you see that we're doing only X values. So there was a dot there, so we'll do included -6. And it goes all the way to that green line, which is 5. Okay, there was a dot there, so we'll include it. And then let's do range. Should we do a different color? So range is low to high, low to high. So I go to my lowest point. It doesn't necessarily have to be at an end. My lowest point could be in the middle. Okay, we'll talk about that. I think there's one, yeah. And then how about my highest point? My highest point, do you see how that's up here? It doesn't have to be on an end. My highest, I just go low to high. It's okay here that it's double. I only care about a vertical line, so I could care less about the horizontal line. That's something different. That makes it a 1-to-1 function, but we're not going to get into that. So my range is, what's my lowest? Is that -4? -4. And what's my highest? The Y value, 6. So, and if you have to draw the line, I know it's going to be a little bit harder on WebAssign, but definitely like on a test, just draw a left, right line, low, high line. Okay, how about our circle or whatever that picture is? When X is -2, how many Y values do I have? 2. That means not a function, okay? Or I could just do the vertical line. I touch it once, I touch it twice. Wherever I touch it, that's a Y value. So there's a whole bunch of lines, right? That it definitely does not pass the vertical line test. I definitely have more than one Y value at some X value. Not a function. You on the homework, you'll just click not a function. But you only have to state domain and range if it is a function. Okay, and this is in the directions, you'll just have to read it. So if it's not a function, there's still a blank for you to do domain and range. Because otherwise it would give it away, right? If they didn't have the blanks there, you'd be like, oh, it's not a function. So, and it's in the directions. For the domain, then you state DNE for does not exist. All caps, or they might mark it wrong. Okay, and then you got to go down to the range and do capital DNE. That's not on a test. It's just on WebAssign. They have to have those blanks. And so that's how they have to fill them in. Because they only want you to do domain and range if it's a function. All right, how about the next one? Or questions on that? We're okay on that? All right, is this a function? Asymptotes don't count as graphs. So even though I'm touching that dotted line, that's just a guiding. So I only touch the graph one time. Every place, it's okay that it's okay that there's a space here. Remember, if I don't touch the graph at all, then I don't even care about it. It's not in the domain, which we'll get to in just a minute, right? So I think every time I draw a line, I only have one Y value. So it is a function. All right, now how about the domain? What's the domain? What does this arrow mean? It's going left. Every place I draw a line, the line goes a little bit further. Every place I would draw a line, the line goes a little bit further. So I actually am starting at -infinity. Remember, domain is left to right, never include infinities, so -infinity. What am I going to go up to, though? As I go left to right, what about 2, right? That asymptote I have to jump over. So to 2, I'm not going to include it because there's an asymptote there. But then union, I want to go right after it to infinity. And then right after it, it keeps up and keeps going on. Too fast? Are we okay on that? Okay. Yeah. Good question. Okay, so it is parenthesis because it doesn't include. If you put a bracket, then you're including 2. And right there, there's an asymptote. So yes, you want parentheses for those. Good. All right, let's do range. Same thing. Now just remember, it's low to high, but this line is going down. This line is going down. So it is negative infinity. Always go low to high. So negative infinity all the way up to the asymptote, which is 1. Don't include that asymptote. So it's going to be a parenthesis. And then 1 to infinity. Right after that asymptote, it just keeps going. Should I ask it now? Oh, what's that? Well, let's do the next one and I'll come back. Question. All right, how about this next one? Is it a, oh, we have to set it up. Is it a function? It is good, except for one line, right? This is great, this is great, this is great. What about this line? How many times am I touching the graph? A whole bunch of times, right? An infinite amount of times. There's a whole section here, not a function. It only takes one line. So not a function. That you'll just click. And then don't forget to do domain DNE does not exist, range does not exist. So, and I'll bring that back down. What about, let's go back to this one. This line is going up and it never crosses this asymptote. Does it ever go completely vertical? Because if it goes completely vertical, then we got this situation. It never does. It gets closer and closer to, where was my asymptote at 2? It gets closer and closer to 2, but it never goes completely vertical. It's like, think about where you are right now, go halfway to that door. Then now do another halfway to that door. You can always get a little bit closer. If you always go halfway, you can always get a little bit closer, but you'll never get to the door. All right, so this, even though it looks, and it gets pretty steep, it'll never go vertical. If it does go vertical, then it's no longer a function, but that's the whole reason we draw that asymptote in. Because it gets close and close and close, but it never goes vertical and it never crosses it either. Okay, how about this one? This one looks like two pieces of a graph put together. Do you see how it's kind of maybe a parabola and maybe a line? Does anyone know what that's called? Have you ever heard of piecewise functions? Yeah, we don't get creative in math. It's pieces of a graph. So we call them piecewise functions. If we take one piece and another piece or part of each and put it together. All right, is that piecewise function not P-E-A-C-E, but P-I-E-C, so piece. Is it a function? Yep, I think it's good. It always, we're good, so function. Now those arrows are fairly important. What is the domain? Kind of like my other one, right? My left, it's always going, this arrow is always going up, but what else is it doing? It's also going out, okay? Because if it goes completely up, then it's vertical, it's not a function. So it's curving up and out. So my domain is negative infinity. Same with this one. Everyone says this is going down, but as it's going down, it is slightly going out. Okay, it's not going completely straight down, it's going down and out. So it is to positive infinity. So you got to think of those arrows. If it's not vertical, then even though it's going down, it's got to also be going left or right as well. All right, how about the range? The range, that might be easier to see, right? Because it does look like it's definitely going down and up. So negative infinity to positive infinity. Questions on that domain? You got to think of it going 2 directions. All right, how about the next one? What do we have there? We have a whole or removable discontinuity. But there happens to be a point up there, but that's okay. I think we're good every place except here, but a hole does not count. A hole does not count. So I literally am only touching the graph the one time. That's the whole purpose of the hole. So this is a function. Function. Sneak it on there. All right. It is a function. What is the domain? Left to right. Is there any gaps? So left to right. We might say, hey, there's something at 3, but is there an x value of 1? It's just in a different spot. But when x is 1, and remember domain is x values. When x is 1, I do have a graph there. So it is from -4 to what? You guys tell me. What's the -4 to what? To what? You don't know what I tried? 6. Yes, you can see that. Remember, we're strictly going left to right. Left to right. Keep in mind, though, that I'm saying there's a graph everywhere. So when x is 1, I still have a graph, even though it's up here. That we don't care about. It's just as long as it produces a y value, that's what we care about. All right, how about the range? Low to high. Now this one we have to be a little bit careful on. Is there a y value of 3 on this graph? There's no y value of 3 on this graph. So we're gonna go, make sure you go low to high. -2, but I have to, now remember I'm doing y values. I have to jump over the y value of 3. And then it keeps going on all the way, even though this is a dot, it goes all the way up to 7, that high one. So we got to do, all right, now where did it start again? -2, -2 to 3. Don't include 3 because we want to jump over 3 and then head to 7. Questions on that? Remember, we don't care that there's an extra point here. For y values, we don't care about that extra point. Right? And the graph goes a little bit higher, so we got to include all the way up to 7. So the whole, we kind of have to jump over for the range. We would have to jump over the whole for the domain, except we had that extra point. Does that make sense? The domain, we have to jump over holes as well. But because we had that extra point, then we didn't have to. All right, how about the next one? Is it a function? Nope, I can draw this, right? I can, even here it even touches it 3 times, but not a function. So remember, just do not a function, you'll click. And then remember DNE for domain and range. And it's in the direction, but just like that. Okay, here we got some spaces. So let's do this last one. First of all, is it a function? I think we're okay because the only issue might be here, but here it's closed, here it's open. So that's okay. So this is a function. All right, left to right. Left to right, is there any space left to right? I start at -4. I have a graph here, and then it picks up right here. Don't think about up and down, think about left to right. There is no space left to right. So my domain is -4. This is going down, but what other direction is it going? It's also going to the right. So it's going to be -4 to infinity. -4 to infinity. There's no space left to right. If I draw a line here, there's a graph. If I draw a line right here, there's a graph. If I draw a line right here, the graph is down here, but there's still a graph. And don't forget this line is going down, but it's also going to the right. All right, and then range. How about range? Low to high. So this line is definitely going down. You like that. So -infinity up until -3. So -infinity up until -3, parenthesis. All right, who wants to do the last one? Union, what are we going to do the last one? Anyone want to try it? Low to high. 3 to 4, close. Low to high. So this starts out, where does this one start out? 1. 1, and then the high one is 4. Does that make sense? You want to go low to high. So this one would then be, there was a closed out. So it'll be bracket 1, and then I think it touches 4. We could argue that, but we'll say that. So those are a little bit hard. You really got to think left to right and down to up. When you're doing down to up, then you got to, don't worry about space left to right. When you're going down to high, don't worry about, well, you do want to worry about space going that way, down to high. Okay, so here we don't care about anything here, but there is a y value of 1 on that graph. And then you want to go up until 4. All right, the last one, there's no graph there. All right, let's take a look at this. Okay, so now our book does something a little funky. It doesn't come up a whole lot, but function notation is that f of x, right? It names the function. Okay, function notation, and it takes the place of y, right? It's the same thing as y. And it's just nice in case you have 2, right? I know that this is now the f function, and this is now the g function. So there's 2 functions on there. It's not like this is not a function. Together is not a function. But we actually have 2 functions on there. And that's why we use this notation, f of x and g of x. Now, our book doesn't always like to put this. So, and I didn't do a very good job. What they'll do instead of f of x, they'll do like a fancy f. And they say, hey, that's my notation for an f function. Okay? So just when you're on WebAssign, it should look a little bit curvier. It's supposed to be a fancier f. And they use that sometimes instead of that notation. And I don't even know how to make the g fancier. Maybe I kind of curve my g's anyways. But supposedly it's a little bit curvier. And that takes the place of the g of x. Oh, we can see. So they try to make their f a little bit fancier, and then they don't have to put this. They try to make their g a little bit curvier, and then they don't put that. So just know that that's the same thing as f of x and g of x. I'll probably always write it. In fact, if we even want to do it here, we could f of x. Maybe on a graph, it makes sense because it gets a little messy. Okay, so what is this saying? F parenthesis 2. That says there's a whole sentence right there in those 4 symbols. This says go to the f function. X is 2, tell me the y value. That's what that whole thing is saying. I have to go to the f function. What's inside here is x. And if they're asking for f of x or f of 2, that's actually the y value. When x is 2, can you give me the y value? So this says go to the f function, They're telling us X is 2. Tell me what Y is. I'll slide it up. Well, we have to see the picture. So I have to go to the F function. X has to be 2. What is the Y? Is it this one? It's maybe not quite perfect, but it's pretty close to, what's the Y value there? When X is 2, we could actually estimate. Sometimes it says estimate. So if we want to say, instead of maybe being, if you say 1, that's fine. If you say maybe like 0.7, that's okay. Do we see where we're at? If you put 1, you're fine. It's probably supposed to be 1. That's what I was looking, but there is one, and this one, there is one on the homework that says estimate. I think this one is actually right on the money, but there's another one later on that'll be a little off. So on the homework, if it says estimate, then it's probably not a whole number. All right, what is this one saying? Go to the G function, and X is -5. Now make sure you're on the G function. Make sure you're on the G function. X is -5. What is the Y value? That one's a little bit better. I think that one is -2. So there's a whole couple sentences there with just that little notation. G function, what's in the parentheses is X. And then they want you to find Y. They want you to find the function, which is then the Y value. Okay, now this one says estimate, like I said, but I think this one's actually pretty good. Go to the G function. When X is 1, what's the Y value? 1. Or no, what's the Y value? 4. Yeah. Just make sure that if you know that we're going to the G function. Okay. When I don't like when they put one on top of another, but that's what they do. All right. Okay, so now this one says, this one you have to write out a little bit more. If they want the X, give me the X when this is the Y, right? Because f of X means the same thing as Y. So when Y is -1, can you give me the X value? And just make sure we're on the F function. So Y has to be -1. Can you give me the X? So the X is 1. But, is there another answer? When, oh dear, did anything go off? All right. What about this point? Does that, am I on the F function? Does it have a Y value of -1? So these, there may be more than one answer. Okay, so you really have to, when they're giving you the Y, you have to scan the entire Y. When they're giving you the Y, then you got to make sure that you scan the entire Y. You can even go to -1 and draw a line. And make sure you get them all. There could be one more. So what is it? It is -3. The X value, -3. What do you know? The Y value is -1. Okay, so when they're giving you Y's, just make sure that there could be more than one. All right, so what does this one say? Now this one says estimate the value. We're going to answer X values. Y is -4. Y is -4, but make sure I'm on the G function. So Y is -4. You can draw a line if you want. Make sure I'm on the G function. You have to give me the X value. Does anyone want to try? What's the X value there? X value. What do we say? So the X, so we're at -4. What's the X value right here? So the X value is -1, -2, -3, -4, -5, and then maybe a little bit more. You're going to give that X value when Y is -4. So maybe negative 5.5, something like that. All the way to negative 5 and then a little bit beyond. And you can always check it. Like just say, okay, I'm going to do negative 5.5, negative 4. I better land on the graph. So if you want to check it, just start at the origin and do your x value and your y value. Make sure that you land on your graph. All right, domain and range of the f function. What do we think? All right, domain, make sure we get f. Oh, goodness, I could almost use another graph here. It is left to right. Make sure you're doing the f values. Left to right, so it is negative 5 to 6. Okay, who wants to try the range? Make sure you're just doing f values. Take the lowest f value and the highest f value. That highest, it doesn't have to be an endpoint. So what's your low? What's your high? Make sure, oh wait, I didn't do, wait, I gotta make sure I'm on the f, aren't I? Maybe should I trace the f? It actually, does it happen to be the same? It does. This line is not drawn because of this point, it's actually drawn because of that point. Can you see? Oh, okay. So we're doing the f function. So here's my low. My high is here, but because of this point, because of that point there, because that is on my f function. All right, so the range is, now you probably can't do that. Okay, that'll do. Range is, who wants to try? Give me the range. Negative 2 to 5. Beautiful. That's it. Negative 2 to 5. Good. Good. All right. When f is 4, can you, what is that asking? F function, x is 4. Can you give me a y value? So f function, x is 4. Can you give me a y value? Like right there. So maybe like 3 point something, depending on how good your graph is, and if you've traced over it enough. This is a y value. 3 point something. I think I put 3.3. Can you see? This one is tricky. I'm gonna get a new graph. Now, these last two are crazy. Oh, and they're not going to fit. Let's do this. I'm going to do this. Okay, this gets crazy. Increasing and decreasing. Increasing is going up left to right. Decreasing is going down left to right. So your brain is looking where the graph is going up for increasing, but you state it with x values. You don't state it with y values. So G is increasing from here to here. Okay, do you see how it's going up the page? That's increasing. That makes sense, right? But I am not going to say negative 5 to 5. That's where it gets kind of crazy. Increasing is from negative 6 to negative 1. Do you see that? That's just how we do it, but it's kind of crazy. You're looking down to up, but you have to state it left to right. Okay, we don't have to put the I because, okay, here's the decreasing. Okay, so let's try decreasing. Decreasing is from here. Do you see how it's going down the page? Going down the page is decreasing, but you have to state it left to right. So how are we going to answer that? We're not going to say 5 to negative 2, even though that's what our brain is thinking. And it does have to think that because that's what's going down. How are we going to state it? It is negative 1 to 5. Negative 1 to 5. Have to state it left to right. And I've looked at this. I don't have a great answer, but you actually include it for both increasing and decreasing. I guess because there's a point there, so that is okay. All right, let's try F. Where is it increasing? Trace it first. Do we see how it's increasing halfway? It starts to go up, but you must give X values. You must give X values. So it is increasing from -1 to 6. Must give X. Can we even see up here? Make sure that you only increasing and decreasing only X value. So it's decreasing here, but I have to state X values. It's decreasing here, but I have to state X value. So it is -5 to -1. And always do left to right. So be careful on that. Your brain's looking one way, but you have to state it left to right. All right, and this one is, do we know what this one is? Where's f of x and g of x, where are they equal? We're actually going to give the x values, and that's where they cross, right? So an x value of 3, and this one, is it at -4? Does that look okay? Where they cross. So at -4 and 3. If it's off a little, depending on how, if you want to say, like I wrote -4.1, obviously on WebAssign it'll be easier, it'll be either perfect, or they will use the word estimate. So that's kind of nice. So if you see the word estimate, then it might have a decimal. All right, questions on that increasing, decreasing. Make sure that you give X values. All right, let's take a look at least a few of these. This is just doing function notation. We're going to do this a couple days. What does this say? F of 3, what does that say? No, we finally don't have graphs. We actually now have equations. Most of the time, we're going to be looking at equations. We're not going to be looking at graphs. So we have, here's our F function. What's in the parentheses is X. So we're going to do 4, 3 squared minus 2 times 3 plus 1. You literally copy 4. I copy, but instead of X, I'm plugging in a 3. You literally just take whatever's in the parentheses, replaces the X. And then if you want to grab a calculator, you can just type it in. 4 times 9, that's 36 minus 6 plus 1. So that takes us to 31. Okay. Now, just be careful here. If you have a calculator, that's fine. You're going to rewrite the F function. This tells me to rewrite the F function. 4. What am I going to put in place of X? -2. So it has to go in parentheses because it has a negative. Then square it. -2, -2, and then plus 1. I'll leave it right. If I leave it there, we can see something. So every place there was an X, there's now a -2. Every place there was, oh, and this one was squared. So just make sure that you square. Okay. Grab a calculator. This first one, what is -2 squared? I think we did that the very first thing on the board. That's a +4. So 4 times 4, this is a 16. Okay. If you need a calculator, that's fine, but you have to square that negative. 2 negatives gives you a positive when you're multiplying, and then you have the +1. So I think I can squeeze it in there, right? 21. All right, what's the next one asking? Instead of an X, write a Z. That's all you have to do. So it is going to be 4z squared minus 2z plus 1. That's all they want you to understand. Whatever's in the parentheses replaces the X. Whatever in the parentheses replaces the x. All right, how about this one? 4, I need parentheses because I'm plugging in a negative. Minus 2, I'm plugging in a negative, and then plus 1. This one we can simplify. What's a better way to write this? We're squaring the negative, so that actually becomes positive. So a better way to write this, we can go ahead and make it 4z squared. That negative does get squared, and so it does go to positive. 2 negatives gives us a positive, so plus 2z. And then the plus 1. Okay, so we can do a little simplifying there. All right, how about, this is important. Can you plug in a quantity? 4 in place of x is going x minus 1, and then I have to square that. In place of my x, I'm now putting in an x minus 1. But then I just keep going, minus 2. What am I writing in place of x? I might have to fold it up. In place of x, I write x minus 1. And then I still have to do plus 1. I think we probably should actually, we could actually multiply this out and make it smaller, but I'll let you leave it like that. Web sign should take that. All right, this one. What is this one saying? I'm going to rewrite my f function, and wherever there's an x, I'm going to write a c. So 4c squared minus 2c plus 1. But what am I supposed to do with my entire f function? Take it times 2. So this is my entire f function. I now have to take it times 2. So the best answer would be 8c squared minus 4c plus 2. Okay, compare that. What is the next one saying? This one, the 2 was on the outside. All right, this one, wherever there's an x, we're writing 2c. So 4, then 2c squared minus 2 times 2c, and then plus 1. Compare those two. Wherever there's an x, I'm writing 2c. This we could, what is this going to become? This would actually, we can square the 2 and we can square the c. There's no plus or minus, so we can bring that in. So this is going to be 4c squared. And we take it times another 4, so 16c squared. This is minus 4c. Do you see any of this? And then plus 1. Okay, so now we can do a little bit of cleanup there. Be careful on this one. Make sure we can see this one. 4, I'm plugging in a c cubed, and then I have to square it, because that's my x. You have to picture the x right here. Minus 2c cubed, and then plus 1. So what's the best answer there? 4, and then it's going to be c to the 6. Multiply those. You want to multiply those, c to the 6. Minus 2c to the 3rd plus 1. Anytime you're putting in a quantity, put it in parentheses. Okay, so now the bottom one, what's happening on this one? We simply write the function with an r instead of an x. Okay, we can do that. 4r squared minus 2r plus 1. So instead of in there, instead of an x, it says f of r instead of f of x. Wherever there's an x, you replace it with an r. But what do we have to do with that now? We have to square it. I think WebAssign will take that. Otherwise, we would have to write it out twice and do a long FOIL. But we'll go ahead and take that. This last one's important. We're going to see this a couple times. So 4, in place of x, I have to put a plus h. And what else do I have to do? I have to square it. In your head, you have to see the x here. If it's a quantity, put it in parentheses. Okay, minus 2 times a plus h, put it in parentheses, and then plus 1. Same thing, we could actually write this out twice in FOIL, distribute and collect like terms, but as long as you're there, that'll be a good start. We didn't get to the word problem, so maybe we can pick that up on Monday. So the last WebAssign, you can try it. You've got 50 tries, and it's just, I think you pick and choose. So try one, if it doesn't work, try the other, okay? It's just a word problem. I should say that because everyone panics a word problem, but it's just, here's a situation, can you match it to maybe a graph? Okay, so give it a try. We can talk about that on Monday. That's not a problem. All right, so WebAssign again, give it a try, okay? Bring questions early, late if you want to stay. See how you do. I can look on WebAssign too and see how you're doing. All right, have a good weekend. It might rain, so great time to do that. Not today. Today, get outside. Don't do that today.
What, tomorrow? It's supposed to rain tomorrow?
I don't know. My husband said it changed.
Hope so.
I know Sunday too, but you know, sometimes it's only for an hour too.
Right.
You know, so who knows? Sunday, okay. I guess Monday, but we're going to be back here on Monday anyway. All right, how are we doing, Shemaine? Oh, awesome. Yeah, okay. I know. I think I've got around. But yeah, if you don't mind staying, let me mark it off and then we'll mark it up. Oh, that's one. Okay. You got one? Good. How do you feel okay? What was the last math class you had? Okay. What was the last math class you had? Did you have like a pre-college or not? No, okay. You're not alone. So, this is great though. Okay.
But like, you know, when you're talking, it comes back.
Okay. Yeah, I was gonna say, I mean, it looks like you're working through stuff. All right, we gotta try this again.
Oh, I didn't.
You know what? We might have done it in stages too.
Yeah.
Trig doesn't come up too much, so don't panic too much. And then at least till we get to 1. Okay, good. All right, so you are perfect. Oh, did you? Okay. Very good. Okay, that's okay. Let me give you a plus before, and then we can grade it a little bit later. But good. All right, awesome. Okay, thank you for staying. Good. I'll get around if you don't say, but. Okay. I'm so glad you did. Anyone who helps, that's good. Carlos, don't go anywhere. You want to leave for a few minutes?
Sorry?
Are you Carlos?
No.
Oh. Bye. Uh-oh, I know Shemaine. Wait, don't leave. I have to know your name now.
It's Anthony.
Anthony! Oh, that's right, Anthony. Okay, I knew that. Okay. Question though? But Carlos didn't stay. Carlos said he was going to stay. Shoot. Okay.
Sorry, no, I was a little late because of the traffic.
Yes, I know. Seriously, they're going to blacktop right outside John's. I know. No, that's okay. Don't worry about it. So if you, let me stop this. If you need, if you want to watch the beginning, you can even just watch the beginning of the video.